Arindam, should you start? Okay, you want to introduce me? No, I can introduce myself. Like, it's not necessary. Okay. Okay. Thank you so much. Thank you for bringing me here. I'm thankful to Arindam and all the other members of CS department. And this time, I do not like the term workshop. It looks like I'll teach you something and you'll learn something. It's not like that. I like the term jamming. Okay, so we'll jam together and we'll draw comics and perhaps we'll try to explore whether we can use comics as a medium to spread education in the domain of CS and math. So I'm very thankful to Sriram actually. His lecture really set my stage. So principle-wise and philosophically our talk is similar, but my medium is different. And this talk, since we have plenty of time, like almost 3 hours, so what we'll do, the workflow will be like, I'll deliver a talk, like 40 minutes, like that. In between that talk, Ullas is here. Ullas is a PhD student and also interested in comics. So Ullas will come and he is trying to develop some comical tool or comics to spread education on CS and math. So he'll present that. Then I'll again continue the talk. So then I'll describe how I am dissecting the talk. And after that, we all draw. So we have papers, and yesterday we asked you to bring your pen and pencil. So we'll try to draw something, anything you can imagine in the domain of CS, math, or anything in science. So like how we can do that, like we can transfer scientific knowledge, or not transfer, like we can make a dialogue between comics, a visual medium, and scientific knowledge. Let's try that here today. Yeah, so Ullas, can you please come and you just start showing your work and you tell what is your idea about comics and CS, and then I'll. So I guess you will be needing this.
No, I have a mic. I'm just trying to figure out.
So you don't need that?
No, I have a mic here.
You have a mic here? Okay. And I guess I just can mute that mic while he's talking.
Hi, am I audible? Yes. Yeah. Okay, so for those of you who don't know me, I'm Ullas, and for those of you who are like in pursuit of happiness, I'm Ullas. You have found it. So in case any of your friends or enemies or anyone in the workshop tell you that I happen to be a computer scientist, they're lying to you. I'm not. I'm not a computer scientist. I'm basically a storyteller. I would probably call myself as a storyteller by passion. I just happen to be a computer scientist by accident, and probably a researcher by no option, you know. I mean, it's just one of these vagaries of life. So I call myself as a storyteller mainly because I have always had this, I would be probably boasting if I said I've had a creative spark, but maybe a creative fire would be a more of the online to it. I try to express myself via stories, poetry, comics, and other different stuff. In case any of you like to read some of my short stories, I've got a few of them over here. Maybe after the talk you can just ask me, I'll give you a few copies for free. But what I thought I would discuss today is one sad thing, or maybe I don't know what to call this. Is this a sad or a good thing? If you happen to be an unfortunate soul who has enrolled in a PhD program in a university like IISc, a very, very common side effect of that is what? What are side effects of a PhD? Happiness. Yeah, I mean, my name is Happiness. What else?
Gray hair.
Gray hair. Thank God I've not yet got it. Or maybe, you never know, Schrodinger's cat. What else? Less hair. Oh yeah, of course, that's possible. Anything else? No, you're forgetting the most important thing. If you happen to be a PhD student in any, yeah?
Lack of time.
What?
Lack of time.
I didn't get you.
Lack of time.
Lack of time. Oh, okay. So you're saying there's lack of time. So that's exactly what I'm trying to tell you. In case you happen to get any kind of free time, which is probably like non-existential, all of your free time is being used in you trying to do some like very nerdy stuff. Meaning something that actually is academic in some sense, which is what happened to me. So I was trying to like dabble around with my area of research. I'm not going to talk about that because if you thought looking at the title of this slide, this is what I'm working on, you're totally wrong. This is not my area of research. So I was working on something else, and then I thought, hey, wait, why can't I actually draw comics to actually explain a particular topic in computer science, which is hashing, and I'm going to show you that. And that's not where I stopped. I went one step further, people. Isn't that really cool? People are going to generally discourage you, saying that all of your nonsense, weird, stupid ideas should be like buried and like, like danced on their graves and all that stuff. You know what I actually did? I did the extreme opposite. I went ahead and wrote a paper on it. How cool is that? Isn't that so cool? It's as cool as you can actually like call it as a polar bear. And this is the paper that I wrote, which I'm kind of like ironically enough, I had to like download yesterday. I just didn't have the like bandwidth to do that, and he downloaded and he got a copy of this. This was published last year in a conference called ACM India's Compute, and I presented this work over there. Neil Dara was present over there, so it's the same work I'm presenting here. You get bored over there, okay? So I actually wrote a paper trying to explain how you can actually use comics as a pedagogical tool, and see, the idea is my plan is like bold and simple. All I aim to do in life is to infiltrate every corner of the world with my ideas of comics and tell people that I'm going to like discuss computer science, like the way Sriram was telling. And in the process of doing that, I'll actually end up teaching them comics and drawing and all that stuff, and they'll never realize that they're actually doing computer science. And at the end of it, a portal to higher dimensions will be opened, and people will from like higher dimensional spaces are going to enter, and everyone will say computer science is for all. Isn't that universal? That's okay. I'm getting carried away. It looks like I'm probably someone going to higher dimensions myself, but I mean, that is the plan. Hopefully by the end of this talk, every one of you would have entered higher dimensions. Who wants to go to higher dimensions? Yeah, I'm happy. Okay, so let's for the moment stick to terra firma and stay on this earth. Like, why aren't people like writing down these things and like passing off this to history textbooks? I like feel sad for that. So the goal for today, at least for now, is my idea behind writing the research paper was to show people that you can explain a specific, probably intricate topic using comics. And typically, in case you have had the habit of reading research papers, which you would if you were a research student, and you find it really enjoyable, you would actually read research papers when you're like going to a movie and things like that. So I do that, by the way. So you'd realize that typically research papers are written in a like very structured and maybe dry format. Depending on your definition of dry, the Sahara Desert would feel envious of you. So I realized that maybe why can't we actually spice things up a little bit? Can I not actually make a research paper entirely in the form of like comics? My research paper is not entirely made of comics. There are like comics here and there, but yeah, the general skeleton is there. And then I thought, okay, maybe let's actually do that. And I took this specific topic of hashing, and you don't want to actually make your readers drop off dead like flies by the end of page 2. That's the basic idea. Preferably, you would want your readers to drop off dead like flies after they finish reading your paper, okay? Probably as a result of reading your paper. So the idea here is, in case anyone is not familiar with hashing, raise your hands. Anybody? Okay, I'm glad you all know, so you don't need to listen to this. But let's say that after the spectacular success of yesterday's workshop, people decided that they're going to come today in like enormous numbers, which sadly the auditorium here is like margin too small being, format thing. But let's imagine a lot of people who come here to the campus. And people realize, how do you people come here to campus today? How did you all come? Cab? Metro? Higher dimensional space. I've already achieved my target. Okay, but maybe some of you, let's imagine, came by your vehicles. I'm assuming your people are familiar with driving. In case you are not, do not feel ashamed of that. I'm a PhD student, so I don't know driving, so it's fine. Let's say you actually took your vehicles and came here to the campus. And because the number is huge enough, there are so many people who come with their vehicles, you will actually have a problem in terms of trying to find space for parking. That's the problem, that the setup that I want to go up with. And this is where we begin. So I'm going to tell this kind of like a story, okay? Imagine the scenario where you have entered the campus and you see that you need to park your vehicle somewhere, and you find that the parking lot is basically a mess. The parking lot doesn't really have space. I mean, don't ask why it's called a mess if it's a parking lot. This is what it says. I'm not sure if you're able to read my handwriting back there. Is it clear, visible? Do I need to okay, fine. So I mean, the parking lot manager, who happens to be like a specially created post for this complex operation, has actually got a minors in computer science. How cool is that? To have a minors in computer science and be in charge of a parking lot. Isn't that your life ambition, people? So this guy actually realizes that the only operations that you're performing in this kind of a space is insert, search, delete. That's all you need to do. And that is all you require to come up with an algorithm, basically. And he creates these slots or spaces for people to park their vehicles. And he says that initially, let's say the number of slots created in this parking lot is going to be equal to the number of students, which means let's imagine there are like 100,000 students, 1,000,000 students, and you're going to have like slots for each of them. And every time a student now drives in, all the student has to do is remember that particular student's roll number, whatever that is, and just drive into that particular spot and park the vehicle there. Isn't that constant time insertion? So that's really, really efficient, constant time insertion. And if you see, this is also advantageous for search, because every time the student wants to pick up his vehicle back again, you just go to your particular slot that you have been allotted, your roll number. All you have to remember in this scenario is your roll number, and that's it. One roll number to rule them all. Bad joke, okay. And now the problem with this, as you can imagine, is you have too much of empty space. That's why it's called as a parking lot. There's a lot of empty space. And this empty space is created simply because of the fact that many of you came here from higher dimensions, not from like your lowly little vehicles, like whatever you call them, like Honda. I don't even know the names of these vehicles. So this actually creates a lot of empty space. How do you solve this problem? This is again because not every student actually requires a spot. So maybe let's say only about 1,000 students need to use a parking lot. You only need to have that many number of slots here, therefore, and that requires us to develop something called as a hash function, which you being computer scientists should know. But let's imagine there's somebody here in the audience who doesn't know that. So let's call this hash function as your student's roll number modulo 1,000, which is basically like the last 3 digits of your roll number. So if a person with roll number 1, 2, 3, 4 comes in, that particular person has to take his vehicle and park it in the slot number 234. And that's basically constant time insertion, because constant as in let's assume that the modulus operation can be done very quickly. It's constant time in essence, and therefore like it's constant time insertion and constant time searching. But you see what the problem is? Yeah, I see some people nodding their heads. So let's say there are 2 people with roll numbers 1, 2, 3, 4 and 2, 2, 3, 4. Both of their hashes have to be 2, 3, 4, which means they're like racing to the finish to this particular slot of 234, and eventually all you end up with is a collision, right? So if you're familiar with the term collision in hashing, this is basically what it is, you know. It's not, in case any of your data structures teachers told you that collision is a process by which 2 keys map onto the same value, your data structure teacher was lying. Collision is basically the fact that 2 vehicles drive at maximum speed at half the fraction of the speed of light and collide with each other. That is collision, okay? That none of your data structures teachers taught you that, did they? They're lying to you. Okay, so now the way you actually resolve this, or at least the way the parking lot manager resolves this, is to actually put some kind of a chain. Do you remember this notion of chaining in hashing? So there's this chain that you actually build where 2 people whose vehicles collide onto the same value need to disentangle themselves, and they do this by actually parking in the same spot, thereby remembering just the same number, and you just have to like pick up your vehicle from this like superstructure. And anyone who comes onto the same spot again with this particular roll number, for example, gets another chain and just builds up the structure again and again. So the problem with this, as you can see, is you can actually end up maybe like dwarfing the highest structure in your campus if you actually happen to make such a big structure. So here now the problem is searching is no longer constant time, because every time you want to retrieve your vehicle from your parking lot, you actually need to like exhibit your acrobatic nature and actually climb up all these vehicles and remove them up. Okay, so the reason is because hash function we designed was really bad. The hash function was such a terribly lousy hash function that it should feel as ashamed as any like PhD student like me, so bad joke. In case you don't take me wrong, I make like all these sardonic things about PhD students because I know what it is to be a PhD student. So we are not taking advantage of the fact that the hash function needs to distribute this like vehicles very uniformly across the entire space. And now having made this realization, the parking lot manager comes up with a different algorithm, which is to use the next available spot in case a particular spot is occupied, and if in this case you see that 234 is occupied, so therefore you have to go to the next available spot, and this is 235. So the student parks over there. So you see, if you get another key which collides onto the same value as 234, you have to use the next available spot, which is 235, but that's also occupied, so you keep on going ahead until you find the next available spot. Do you guys see a problem with this as well? Being computer scientists, you should of course know what the problem is. So okay, if you want to search for a particular vehicle, searching is easy here, because if the vehicle is not found, you find that you eventually end up reaching an empty spot, and having reached the empty spot, you decide that this particular vehicle was not found, and therefore it's not there, the key is not found. Problem? What's the problem with this?
Your vehicle may occupy somebody else's empty spot.
Why would that happen? Collision? Okay, I mean, technically here you would say collision, because you wouldn't call that collision. Collision would happen when you happen to use the same key for this, but here you are actually making sure that you're using the next available spot. Technically you might still call it a collision because the hash functions hash to the same value, but you're actually like resolving the collision by using the next available spot. That's not the problem. The problem is, yeah, excellent. So that's exactly what the problem is. And if you actually happen to remove one of these vehicles, so for example, this person who had originally parked in 235, whose hash function was 234, removes off his vehicle from 235, you have actually created a vacant spot. Now the person who is trying to search for this particular vehicle, which is here, which was put here because it had collided originally with 234 and then went to 235 and not finding a space there went to 236. If this particular vehicle is now being searched for, you will see the problem. So you will see that this person searching for this vehicle not find it in 234, will have to go and search in the next available spot, and you'll find that this spot is actually like vacant, and you'll assume that the particular thing was this person is actually not present over there. So the way we solve this problem is by actually putting a tombstone here to indicate that you actually have this a logically empty spot. Okay, so this kind of like concludes my presentation. These were all the comics I had on this particular topic. If there are any questions, I will take it at this point. See, this kind of a workshop is an excellent space for eminent speakers to come and discuss about their fantastic ideas. Unimportant people like me are only here to provide some incidental entertainment, okay? So in case you happen to have gone that as well and good. Questions? Doubts? Yeah.
So, I love it.
Thank you.
This is beautiful. One of the problems with this sort of like physical metaphor, so this is actually a question I have for the whole afternoon, right, is with comics we can draw these very beautiful physical metaphors, and the problem is people draw all sorts of incorrect conclusions from the physical metaphor,
Yeah.
right? One of the classic ones is, and this is sort of reproduced here, that a variable is a box. When people teach programming, they say a variable is like a box, you put a value in it.
Yeah,
Right?
which isn't
And then
right.
when you go and study it, students think, well, if it's a box, that means I can put two things in it.
Yeah.
You can't put two things in a variable. That's not how programming variables work.
True.
So the same way I noticed when I was really curious to see how you do chaining, and you sort of fudged over the whole thing. You're like, oh, some stacking, acrobatic stuff. But if I think of it metaphorically as a chain, now I can't get an element out of the middle of the chain because
Everything is wood. Yeah, right,
so
right.
I wonder if you could comment on that a little bit.
Okay, good point. So the right takeaway here is, maybe I should have put this as the first slide. There should have been a disclaimer in my first slide that no animals have been harmed in making of these slides. However, although mathematical rigor has been sacrificed, and that's the sad thing about this. Maybe that's the sad thing. It's not. Maybe I would call it mathematical rigor. I would say like accuracy and rigor in general has been sacrificed. So I have made a lot of these. What do you call this? Approximations maybe, or simplifications, just so that I could ease my artistic process, but not the rigor of this.
I don't think that's what you meant.
It's not?
No, I think the presentation is rigorous enough. It's the fact that you have to use a you have to use a physical metaphor. And the physical metaphor is where the problems come from. It's a different problem.
Oh.
When it's just an abstract chaining thing,
Right.
there's certain detail that I don't have to worry
Right.
about.
Right.
That somehow any drawing you draw is going to introduce a visual metaphor that isn't part of the logic.
Correct.
That's not a lack of rigor. That's just a bogus element, and then students sometimes get fixated on the bogus element and forget the thing they're trying to learn. And they only once they know it, we don't have this confusion because we already know hashing.
True. Yeah. I didn't realize that. Thank you
So
for
in
that.
fact,
So
part of what I'm trying to say is some animals should have been harmed. Because if you do the user study, that's when you find out which details are distracting users into learning the wrong thing about hashing, and then you come up with a better visual metaphor that doesn't have that problem.
right. Yeah. So maybe the takeaway of this is it's probably good enough for you if you draw comics or use storytelling as a medium to explain your concepts. But if you're doing that, you have to work through the details because the stories hide behind a lot of extra stuff which actually aren't exposed, like how Sriram actually pointed out here. So thank you for that. Any other questions? Comments? Doubts? Okay, I think lack of anything implies that you are like completely bowled over. Thank you.
Can you help me to get back to you?
Sure. Yeah, tell me. Oh, yeah. So in case any of you are like curious, I have drawn a few comics to explain different topics in computer science. I can share them with you. It says that none of them take a specific topic like the way I've done with hashing. None of them take a specific concept and explain it end to end. This is probably the only one where I've actually like taken the effort to take a specific topic and explain the entire thing through it. So for example, I've drawn a few comics on maybe garbage collection, but that only explains a specific aspect of garbage collection, like reference count or something like that. So I don't have anything which actually discusses something end to end, and that's actually a great effort for the community to put in to actually develop a set of maybe comics. I'm not saying comics in particular, any kind of like easy artistic material so students can relate to it. Okay, thank you for
why not like we draw that comics if you have some idea today? That is the goal of that session, right? And we really do not need to be worried about the drawing, but Sriram point is very important actually, you know. So the metaphor, what I think he was trying to focus on, if you're using the wrong metaphor, which is not mute.
Yes, mute.
That means previously it was working and mute. Hello, yeah, now. So thing is, yes, we have to be very cautious about the metaphor because visual could be very like illusion kind of thing. That is problematic. So yes, that's why like we need to learn the tools also. Like it's not about, so thing is, from Ulla's talk, what you saw, like some sort of stick figures, and he was trying to use some metaphors, and the language, how he was writing that thing, like, oh no, there is no parking slot, something like that, which is not academic writing, you know, like our daily conversation, which is very important in comics actually. That is the process of reading and understanding. But metaphor is very important thing. And like there is a couple of slides where I'll show you some metaphors. Mathematicians love to use metaphors, and I'll show you that slides. But yeah, before that, let's discuss what is the plan of today's talk actually. So this is the plan actually. Okay, so there are 3 parts. One is, initially I've discussed like how comics could be useful in CS and math education, whether it is useful at all or not. Because there are some problem like in other STEM education, comics might be useful. I'll show you the data in the next slide, like biology. It's a very visual science, right? So if think in this way, if I am asking some comics artist, I need to draw that concept. It's very easy to draw because there are some physical objects or some cells, like some DNA, we know the structure, the shape, or some chemistry, suppose, like at least they can fill in that panels that with some beakers or some scientists or anything physical, but math and CS is quite abstract. So perhaps there is some problem or perhaps there is not. So the computer scientist can focus on that thing today, like how we can make a comics on CS and math education. Second part is, okay, if you really can do that, so it's better to learn more about comics. So what is comics? We need to know that. It's not about just a couple of pictures and just a couple of pictures within some box and some balloons. There are some text. It apparently looks that very simple thing. It's not, actually. If we really can learn the deeper structure of the comics, perhaps we can think like a better comics, and we can transform a CS or math topic or other science topic better way. And third part is, since I'm a comics artist, I'm not a CS scientist, I'll show you some slides like where I have some confusion. Because comics, I see a kind of it's kind of information flow on some two-dimensional space. I see in this way. And whenever I like start drawing a page, I feel that problem. Like I have every sort of image in my mind. If you ask me to draw them separately, like illustration, I can draw that. If you ask me to write them separately, like a writer, I can write that. If you ask me to draw in one page, one image, and one text, I can do that too. But within one page, how to flow the story using text and image, I always feel problem. Okay, so I will discuss with you. Perhaps you can suggest me some better solution, or you can like using your computational mathematical brain, perhaps we can do something together today. Okay, so this is the structure of today's the talk part. After it's done, we'll draw comics together. Okay, so let's discuss first about that problem, comics as a pedagogical tool in CS and math. So this is a data. Okay, it was done by Matteo Farnella. So Matteo is a very good friend of mine, and when he was doing his PhD in UCL, he published a book. Apart from doing his thesis, it's called Neurocomics. So he is a neuroscientist. Then he moved to US in Columbia University, working on that, like how comics could be useful in STEM education. And he published a paper, and this is the data. And if you can see that, there are like several studies like how comics could be useful in different STEM education. And it's general science, biochemistry, chemistry, biology, economics, virology, environmental science, general science again, stem cells, nanotechnology, human anatomy. Where is CS and math? At least in this study, there was nothing like he couldn't found like comics really was useful in teaching CS and math. Okay, so this was this study. So I'm not claiming that this is the study, this is the ultimate data, but at least this paper claiming that hardly there are any significant work on comics that could be used as a pedagogical tool in teaching CS and math. But there are certain good books. And like all the physical copies are here on that desk. Okay, so after the talk, during you will start drawing, you can flip through the pages. So this is one book, which I mostly love that book, which is Logic Comics. Second book, the Logic Comics is basically Bertrand Russell's a lecture, just one lecture, okay? And many people are coming, and it's a very fictional thing, like many like Gödel's and other mathematicians are coming within, and throughout the book, basically, Russell is giving a lecture. And why logic is the basic pillar of mathematics. This is the like main principle of that book. And it's a very funny book also, like it's not a very serious thing, okay? And second book is Thrilling Adventures of Lovelace and Babbage. It's again a fictional account, and Ada Lovelace concept around computation, and Babbage dream about to make the Babbage machine, that dream machine. And this is Imitation Game. I am sure like you all have seen that movie. It's about Turing and how he actually during Second World War, he was helping British intelligence to decipher that Nazi machine, yeah? So this is one page from that Russell book, okay? So here you can see like this is Russell, the cartoon version of the Russell, and here you can see like Kurt Gödel is appearing. So like this way, in that comics, they keep coming, you know? So this is not a book to learn about logic. If you really want to be a serious mathematician, you have to read books, something like Elements of Logic, something like that. But this is a basically catalog, how historically the ideas of logic was developed. It's a very good start, could be. Okay, so if you are not initiated to that topic, and you are not feeling that urge, perhaps this is a different way to provide you the avenue into the subject. After that, you feel inspired or not, that different issue. But this is just an avenue so that you can have that catalog. Okay, so because mathematics is a very old subject, and like mathematicians really carrying that whole burden, like from centuries, different like paradigm shifting ideas that keep coming. No? So this is kind of a catalog book, like how different logical people came and they proposed something and logic was developed. No? So Carnegie Mellon University is using that book really in their CS curriculum. And in Qatar, their Qatar campus, there's one professor, you can see that I took that screenshot from their course curriculum. And they're actually using Logicomics. Again, that's the same point, like it's the first avenue. After that, definitely they have to read the serious textbook. So this is one proof that like people are feeling that yes, like comics book perhaps we can use as a teaching material. And this is page from Adventure of Adolescence and Babbage, you know, so you can see so it's drawn in such way. So while I'm showing you those slides, I would request you to focus what sort of elements you are getting from those slides, like in terms of visual elements, how their styles, in terms of the writing part, how the relationship between the visuals. I'm not mentioning that. You just observe how these things are playing around, you know. Like if you hear how the text and image is in a relationship on that page, it's completely different from that page. Okay? So there is no right or wrong thing. How you can make that marriage a happier marriage, that is you. That is up to you, you know. This is from that Turing book. Okay? Again, a different style of drawing, but quite close to that Bernard Russell's book, Image Within Box, which is called Panel, and the story is flowing in such a way. You know? Now come to another different kind of book. So far the book I was showing is just kind of a history book, the history of development of that subject, and reading the history and going through the history of science. If you are inspired enough to actually go back and really like collect some real textbook and read that subject, are you inspired enough or not? And also learning how the field, the concept was developed. It's not learning only about the people, it's about how the idea was developed, okay? So these are the history book, all these are. But these are technical book, like Larry Gonick. Larry Gonick is a very high, like in his website, he called himself a high educated cartoonist. And yeah, and actually he is. So Larry Gonick studied math in Harvard, and he actually did his summer internship in TIFR Mumbai in late 70s. He came here. Then he went back to MIT, and MIT asked him to do some K2 education program. Then he thought like Harvard and MIT is a very toxic place to study. Then he became a cartoonist. He actually is a migrant from Argentina. And he's like one of the richest cartoonists because every year he published book, every sort of book. Cartoon history of genetics, cartoon history of environment, cartoon history of American Constitution. And this book was really good book actually, but it is out of print now. So in Internet Archive, you can get it free. Okay? And if you are interested, you can take a printout. And there's the second batch of book. It's by Gene Lewin. So Gene Lewin is a school teacher in US. And he was really interested to teach people about coding and computer science. And he thought, like Sriram, that it's not possible to add one extra class. So how I can, in the art class, how I can transform the art class into a math and CS teaching class. And because of that, he got MacArthur Genius Grant. So he became a very big shot. And I found, like layman like me, really useful book. I'll show you some slides. Then you can understand how really comics could be useful. I don't know whether useful or not, at least joyful to people like me who are layman in CS and math. I'll show you inside page of the book. And this book, I really didn't like that book. Like I found that story is weak, but very novel attempt. It's published from Princeton University Press. It's a murder mystery, and you can see like prime suspect. Okay, so it's about prime number, and it's about mostly they discuss permutation and concept of permutation, prime number, integers, and about the number, the science of the numbers through a murder mystery. Okay, so these are very useful books. So here I got a copy from library. You can flip through the pages. So this is the initial pages from Larry Gonick's book. So he started with Claude Shannon's theory. And basically what I found, he was trying to simplify through comics, like a story, Claude Shannon's seminal paper. And Here, if you are interested, you can read that paper. He published later as a book. And if you do not understand the exact paper, you can at least read that paper published in Scientific American about the mathematical basis of information. And that Larygonics comics book start with that, how Claude Shannon and Weaver basically was working with that information. And then like his historical quest start from Claude Shannon and move forward, okay? And this is Liu Yen's book, that Secret School of Coding. So here the story is, why story is very important. And here the metaphor, you know. So he was really worked on the metaphor, because that metaphor is not illusional. What the function of the metaphor is very perfect. It's a bird, if you could, it's a rat, that would be same. How the here the function of the metaphor is the blinking of the eyes, which is really the constant thing. So you are drawing some bird, so here's the evil bird in their school campus, or you are drawing some rat or some lion, it doesn't matter. You know, so choosing the subject matter as metaphor, you have to be very cautious. That's why like Sridham's point was very important. The function we have to, the function of the metaphor, what kind of function that metaphor is serving. So you can see like it's really written from the school kids, basic like that binary system like he was trying to, so the first part of the book. So there are 6 parts in different aspects of computer science. It's really about computation and computer science, not very big idea of math or something. And this is from the prime suspect. So again, and like I'm sure you're observing how the styles are different, storytelling techniques are different, the relationship with image and text, how they're flowing on the page is different in all these comics. Okay, so this is like how they are basically trying to say the concept about these numbers and the permutations. So there is the hard copy, so you can flip through the pages. So I'm not explaining, like you can see by this. And this is XKCD. This is very important comics, I would say, because they are really not focusing on drawing, and which is very important because most of the people think they cannot draw. So I would say the stick figure, like Ullas was also using stick figure, this is enough. If really can write and write properly, you really can create some argument properly, stick figures are enough. So you really do not need to draw like that. So you might think like, I cannot draw like that, how can I draw comics for, and how can I teach computer science or any kind of science through comics, but I'm really interested. What should be my way? So this should be your way. If, yes. Yeah, I can understand, like seeing your stick figures. So XKCD, like it's a web comics basically, but there's plenty of book written by Randall Mould of What If, and there are like 3-4 more books. Yeah, how to, yes, right. So I would suggest, this is the mathematical jokes, not mathematics actually, but you should go through XKCD. Okay, so far I'm sure you observed that in comics, there is some sort of image. Some people draw it realistically, some people use stick figures, but they are not really using writing, academic writing. Their sentence structure, how they're constructing the sentence is really different. So this is the basic structure of comics. When they are making some dialogues, there are some speech balloons. So every elements are very important in comics. So these are basic thing of comics. But what is comics? Okay, so there must be some definition. So there is plenty of definition, but most accepted definition is, so here I am deviating little bit from CS math science part, and I'm entering towards the second part of the talk, which is, if you really want to make a comics, you know what is comics first, okay? So this is the definition, okay? Which is juxtaposed pictorial and other images in deliberate sequence intended to convey information and or to produce an aesthetic response in the viewer. So that part I really do not believe, that aesthetic response, because I do not draw superhero comics or something like that, like just like simple memoirs. Perhaps someday I'll do, but so far, like my job is to like communicate science and creating educational material through comics. That's why aesthetic part I can at least like sacrifice, at least up to a sort of level. Aesthetics is good thing, it's not that very much important. We shouldn't carried away by aesthetics. Okay, so this is the definition. You all like it's juxtaposed, it's image, juxtaposed image, deliberate sequence. But what is the sequence? It's linear or circular, any other kind of sequence. We'll discuss, we'll come to that. But so using that thing, that definition, let's see if really, again we are testing, can transform a really researched paper into a comics form, or at least we like add some comical element as per the definition into that paper, and we can dissect that paper into a like comics thing or not. So this is a very famous paper on small network dynamics. It is very applicable in biology, that's why I know that. So since I'm trained as a biological scientist, so I cannot claim that I understood all the mathematical part, but I really liked how they were dissecting that thing. So in the paper was published in Nature, it's not was written in comics form. But in Brett Victor is a data scientist, and in couple of years back in Columbia University, there was a huge conference on data comics. So all the data visualizers from all over the world, they gathered, mostly Edinburgh University, two guys, I forgot the name now. They gathered, Matthew Farinella was the one of that organizer. They were basically trying to do how we can transform data into a comics and we can convey it. It's not data like daily data visualization, like different kind of chart and graphs, it's not like that. They wanted to add story part in that. So from that conference, actually, that thing emerged. And this is the structure. So here, they are keeping the exact form of the paper, but the writing part, they are basically dissecting, and image part, they are adding corresponding to that paragraph, using that idea, that juxtaposed image in some deliberate sequence, okay? So here is the claim of that writer, that if you focus on that below part, finally comic style, he is not saying exactly comics. Comic style needn't mean characters, dialogue, word balloons, or sound effects, let alone superheroes or anthropomorphic animals. The comic form is about sequences of tightly integrated words and pictures, together conveying a message more powerful than the sum of the parts. The potential of this form to explain difficult concept is unmatched and underused. So underused part is important for me. Unmatched I cannot claim. Yes, I really like that video game part. So I like movie also. So unmatched I cannot say. But yeah, this is the claim that yes, there is not needed that we are using speech balloon or some characters. But still, we can transform a scientific article into a comics form. We can do that. Okay, so this is the thing about basic structure of the comics, but there are some deeper structure also. No? These are the pillars of science comics. So this was at surface level, how a comics look like, a comics page. Here, like what we really need to focus on that. One is visualization and design. It means like what you are, ultimately this is a visual media. So what you are going to draw, or any, if someone copying from some image, you can use some paper cut or anything like, you can be very creative, but what is your visualization? This is important. Narrative, story, and character. This is also important. Okay? It's not like that previous paper you just, you are doing that. Perhaps this is not a very best way. So you have to use some narrative or story, like in Sriram's lecture, the dog was keep coming. Why? These images are not our daily image. People would lose interest, you know. Like dog, cat, sunset, these are part of our daily image. We need to use these things. And the metaphor, which is I found very blurry part, and I'm personally as a comics artist, I'm very cautious about that, using that. So let's see. So, yes, please.
So I'm a little surprised by the way you've written this.
Yes.
Because it feels to me like there's a very deep ordering.
Yes.
It seems to me you want to. It seems to me, I don't think this is on. Okay. It seems to me you want to start with the narrative, story, and character, and from that figure out the metaphor. Can you talk about the ordering between these?
No, yes, a very good question actually. So I can only answer that thing as a comics artist, what is my procedure. So I would say this is very random. But personally, I feel I'm a visual person. The visual comes to me first. But I know this is not enough. So then I write the story, okay, using that visual. So the comics thing is, I'll show you some pattern, what is the most modern pattern of making comics. patterns, like that sequence, that exactly answer to that question. I'll show you some patterns. So it's not like linear sequence like, what is the order? So like, if you search in internet, there you can find that how to draw comics in a Marvel way. There is one like series. What is their method? When they write the story first. Story, not comic story. So it was basically presented by Stan Lee, all the famous writers, the Spider-Man and other superheroes. He wrote down the story. Then scriptwriter divide the story into pages and how many dialogues will be in one page, something like that. Then it's go to the penciler. Using that script, that text, the dissected part, they pencil it. Then go to the inker, then the colorist. This is the Marvel way of in some real linear order. But modern comics artists who basically want to think during comics making, they do not follow this thing. There is no such order. So I'll come to that. You remember that image. I can come back to that image again while I will show that, so we can discuss again, okay? So I wanted to show you this comics because this comics comprises everything is here. So this is by Larry Gonick. It's proof positive. It's basically PCP theorem. So if you're a computer scientist, you know that, what is PCP theorem. So Larry Gonick brought two metaphors. The thing is, Larry Gonick didn't brought that. It's Arthur and Merlin, it's mathematician brought that. Okay, so if I'm not wrong, in 1980s, Babai brought that when he was writing that paper. So here is Martha, but Larry Gonick didn't throw out that metaphors. He used that. Because mathematicians, when they're writing the paper, like the characters of Arthur, so if you do not know that Arthur is the king, so he is basically like a verifier. And Merlin is a wizard. He can give any kind of computational solution, but he's not that honest. Like, he can make mistake. And Arthur verify this. And there are some certain ways. You do not have to go through every point, like certain ways you can verify. I'm not going into deep into that, you know that. Yes, you want to tell something?
No, I was just amused by the fact that Ullas took the metaphors that had been taken from the world into hashing
Yes.
and brought them back out.
Yes.
Like, we only use the word hashing and collision because we think
Yes, yes, exactly. Yes.
they visualized exactly right.
Right. So this is, if you search, like, this comics is out of print now, so that's why I mentioned that source. You just search in Google U Chicago Theory Group, Arthur Merlin, you can get the comics. I'm not reading that thing, so you can found that thing in internet. But what I wanted to say, my point is, it's a very complex thing, a very complex idea. Larry Gonick, like, he took that challenge, and he kept his belief on mathematicians, the exact metaphor they used, and he made up a story. The story part somehow little bit creative by Larry Gonick, okay? And he like imagined that character. And it's not a very abstract character. He exactly imagined like in myth, like that folktale, how they look like exactly. Perhaps they should look like at least one king and one wizard. So this is like how that comics is going on. Also, if you focus here, what is my point? So initially, when they are talking basically nonsense, like building up the comics, what is the context of the comics? Larry Gonick was very creative. But how he is ending that comics? He is using equation numbers, and here, if you see, then in 1989, wizard named Learned Fortna and Nishan, like I can read, and Karloff, right, Karloff, yes. So actually there's a long history of PCP theorem. It started in MIT in late 1980s. Then these guys make some more simplified proof. Then in 2005, who is the name of it? Init, right? Init Dinu, right. So Init Dinu came with another proof. So thing is, Larry Gonick, initially he was going good. At least like I have no one to criticize him. Definitely he's a very cartoonist. But at the actual math part, where he really had some work, he actually phrased that comics in such a way that, okay, then some wizard came, so here there is no role by the Merlin. Actually, he was depending, so mathematicians are actually wizards. They did something, then, the proof is done. So this was my problem with that thing. And from here, actually, I thought, so perhaps this is really tough to transform a complex thing into a comics or another thing. Perhaps Larry Gonick was really intelligent. He had some solution also, but this was commissioned by Discover magazine. and Discovered magazine only assigned him 2 pages. So perhaps, like, like this business magazine business run in such way. Anyway, but so this could be an example how we should draw a science comics or CS comics, the previous half, and later half how you shouldn't draw a science and math comics. So both thing is there. Yeah, yes. 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 Yeah. 60 page, na? 12 classes, yes. So, yes, exactly. So, I'm sure that perhaps this is not possible. And just Larry Gonick wanted to create that avenue. If reading that comic, someone is interested to know what is actually is not written in the comics, perhaps. So, this is the one comics. And also here you can see the structure. So, when I'll show you some slide, please observe what the structure they're using, like some boxes or something else, how they're using the text and the dialog box or something like that. So this is the end of the proof. And so this is the system we are discussing, right? Like the comics page look like a grid system. Here I am heading towards the third part, where I would be needed your help, and perhaps Sriram's questions answer is here. Or not answer, perhaps we can get more avenues to discuss more. So this is a basic grid structure. So there are these grids inside that boxes are called panels. That means you have to draw inside panels. It's not necessary you have to draw inside panels. So you can erase the boundary of the boxes, And this space is called gutters, which is negative space. So we think like in comics, this is just basically to differentiate 2 spaces, which is called panels with some another space. It's not like that. Gutter is very functional. Gutter basically determine the time and space and its frequency. So you can change the width of the gutter, just position of the gutter. You can change the reading sequence. I'm showing you. In fact, you can figure it out by yourself, how it can work. I'll show you some panels. And if you're changing their width and the width of the panels and the gutters, just like wave function, you can change the frequency of reading. And you can add a pace to any event. In this way, you can use their geometric shape, their size, and you can add the space-time variability within a comics page. There are many other things, but this is very basic thing comics artists do. So you can see there are 4 panels, 9 panels, 8 panels. This is 9-panel grid. I really want to tell you about that. So it was, I would say, invented by Alan Moore, if you have read Watchmen, or at least watched the HBO series or that movie. As per Alan Moore's, 9-panel grid is the most symmetric. And you can basically manipulate that thing, erasing, suppose, that boundary. You just can change the sequence. Anything, if you just erase one boundary here, you just can change the sequence. So how we can change the sequence this way? So from where basically you are entering into the page and how the information get flowed. And you see, just you are changing the position of the grid and their relative position, how they are in symmetry or not. That's how your story will flow on that page. Like here you can see, this is a grid, and these are called blockage, the T-junctions. When you are using, just changing the size of that panel and changing the position of that grid and using T-junction, that immediately reading sequence gets changed. So how masterfully you can do that on a page while you are making comics, that will determine really you can put your ideas on that page or not. Here I am facing this trouble. I really do not have any concrete way, like you computer scientists want to do that actually when you want to run a process. This is very random to me. Randomly I get the idea. Otherwise, I have to believe in some established system. I have 4 image, 4 sentence, I will have that space, I will divide into that. But that I am not getting that creative satisfaction. This is just I'm following something easy path. Really, the idea I have in my mind, how I can flow on that page, I do not know that. Perhaps you can tell me today. Okay, so this is the basic thing. You can see grid, this is blockage, this is separation. The separation is very important thing because if you are drawing like that, you are filling a page. Here A, then reading sequence will be B, definitely horizontally we read, and then it will come across the C and D. If you are not putting any image within that negative space, which is called wide gutter, that's why it's separated. If you are putting any image, any small even motif, any logo, then it will be not A to B, it will be A to E, somewhere in between that negative space, then again it will go back to B, then it will come across to C, then again E, then D. the reading sequence automatically will get changed, you know. So from that here you can see that. So it's there's a good book by Visual Language of Comics by Neil Cohn. He's a professor at Boston University of Cognitive Science, but he always work on comics, like how our processing of language, how information flows on the page. So this is the basic thing. As simple as that. These are the boxes. Your idea is here floating. This is the basically gutter, and you are jumping from one panel to another panel. How to jump in which pattern? I feel problem. I'm sure every comics artist in the world, they feel problem. Okay, so this is the basic concept of jumping from one panel through the grid to another panel. Okay, but here is I guess is the answer of Sriram's quest, the order. So if first metaphor come, or the visual, or the story what. So it's just like language. You are processing a language. You know, it's a tree-like structure. But in modern comics artists say no, it's not like that. So from that paper, you can see, I'm reading it out. As summarized by comic scholar and educator Nick Susanis, the special interplay of sequential and simultaneous imbues comics with a dual nature, both tree-like, which is hierarchical, and rhizomatic intervene in a single form. Okay, so it's a rhizomatic structure in terms of creation, in terms of reading, in terms of flowing the information. Why rhizomatic? I can discuss that. Like whole day I can discuss that. So you please ask me that question. Why this is rhizomatic? Because actually in comics, image and text, they are not complementing each other. They are not helping each other. They are some, like if I follow that thing, it's some braiding form. So braiding is a very, like mathematicians are fond of braiding, especially the fluid dynamics people. It's braided, it's entangled with some knots, but not crossing each other path. Okay, so if you do not know, braiding is basically two facing plane or system where there are some nodes, and they are basically connected by some, if you can imagine, some ropes. And if you see, they are crossing their path, but it's not actually. In G-axis is that like that. Okay, so in DNA topology, like topologies basically deal with that thing. So comics is actually like that. If you focus on that inner structure, the image is not the actual image. The text, there must be some context. They are connected with that image, perhaps some previous page. It's very interwoven thing. It's not 1, 2, 3, 4, then 5, 6, 7. It's not like that. In terms of reading and in terms of the structure. Now to answer Sriram's question, when I think personally, I also feel like that. I always go back to that previous node. And it's very rhizomatic, I feel, in my head. It's not like, okay, I know the story first. Now what sort of metaphor I need to derive or need to invent. Okay, it's when it's done, what sort of image I need to create. So you can argue that, or go like, this is very random process perhaps. Perhaps you can tell me some solution. But I work in this way. And like Nick Susanis' thesis is like also like that. So if you do not know about Nick Susanis, so Nick Susanis did his PhD from Columbia University, and in world, he was the first one who made the whole thesis in comics form. So his thesis is a comics book, which is title is Unflattening, and Unflattening is the antithesis of Abbott's Flatland. Okay, actually. So Nick Susanis is trained as a mathematician. So he did his undergrad in mathematics, but PhD in visual language, and in comics form, and he wrote the thesis as a comics. And Unflattening is the comics book in the history of Harvard University Press. They so far published only one comics book. This is Unflattening. So this is his thesis. I'm not claiming that he knows everything, but I liked his thesis because I found similarity with my way of thinking. And this is Groenstein, he's a French theorist. He used that word. So braiding is definitely is not coined by him. Like braiding is used by farmers, braiding grass. And like indigenous people braid grass, and like here, in every cultural domain, braiding is there. But Groenstein used he loved mathematics, and he told that in his book, which is System of Comics, actually image and text are in some mathematical relationship, and they are sending signal to each other, and they are resonating. And when that resonance is happening, some huge vibration is happening, and when that comics works. But again, this is very theoretical part. How actually it works, I do not know that. I really like their theory, and I just found similarity with my way of thinking. So just last part. After that, we'll start drawing, we'll start discussing. So this is how actually that braiding part or that rhizomatic part really work, actually. So what is your thinking process actually? Like I am facing problem in thinking the information flow within the page. So I also see that as the information flow. But I found, okay, so there are some lines. If I fold a page into some boxes, like I'm folding a page, there will be some crease mark, and it will create some boxes, rectangular boxes. And if I start a point, and I think, okay, this is my bad day, or a good day, it's a mixed day. What was my moment, a bad moment? Like yesterday. It was a very good day for me. Weather was super good, so that x-axis is the good and y-axis is the bad. If you are plotting that, your thought on a page, and one box corresponding to the x-axis are good and y-axis are bad, suppose. So your day will be somewhere around across the line, right? On the tangent. So you are plotting. Then I came here. I was very happy. I saw Arindam. He's my school buddy. And I started meeting other people. Then I fell down. Okay, here. So perhaps that graph is going towards that bad day part. But luckily, I didn't broke my leg, so I can leave that to again good day part. In this way, if I plot my whole day, that means my quanta of thinking, I can get a plot. This plot is the flow of the comics, actually, which is exactly what Paul Klee told. So it's a line is basically a dot for a walk. Now that every box have a plot line, I know that like it was good or bad. I know my thinking, right? Because I was plotting. If I write correspondingly, it will create some text. If I draw correspondingly, it will create the whole comics, right? So this is the structure of the comics. It's not like the 1, 2, 3, like grid structure, 4, 5, 6, something like that. And if I create more pages, there will be more pattern like this. So actually, the idea came from Lawrence Tristram Shandy. It was a very old, like 19th century text. And in that text, there are some sentences are missing. And to explain the thought, they use some patterns. And this is another book you can map your whole day. So this is the whole idea. This is another piece of Nick Susani. So his claim is like that. What is the exact pattern of your story flow itself? It's not about what is the structure of the comics, whether you can transform it into a science story or not. This is a science story. It's a very complex science story. So you all know that like our entropy of the whole universe is increasing. Then it's the paradox question, like how life can form. So if someone want to really imagine that kind of abstract thinking, which is really abstract, this is really abstract, you really cannot think that. Perhaps you have to dissect your thought, your all arguments, your all teaching, all reading, everything, and you create some bit of information. Now you have all that information. Okay? Now how you can organize that information? You should have for some pattern. Here the pattern is the metaphor itself. Because you just suppose you are doing some linear fashion, then it meaning something. There is some origin and there is some end. But if you are using that spiral pattern, your understanding about the workflow of that whole process would get changed. Exactly, Nick Susani did that. This was published in Boston Globe. So where is the reading sequence? From where you'd start? From anywhere, actually, you can start this comics. You know? So this is actually the modern science comics, where information is not like just 1, 2, 3, only juxtaposed image, deliberate sequence. Of course, it's deliberate. But here, the interrelationship between the image and the text and the pattern itself is the metaphor. They are in some resonance. They are wholly creating a story which is braiding, which is the rhizomatic structure. It's not a tree-like structure. If you think in this way, like how the information is getting flowed. And this is one scan from his book. And this was the actual title of Ulla's paper. If a picture is worth 1,000 words, why not teaching through them? And Nick Susani used that thing to end that his thesis. A picture is worth 1,000 words. Okay? And this was from his book, How We Learn Language, which is hierarchical and tree-like structure. And this is how comics work, which is rhizomatic. Now, if I ask you, what is my problem? And perhaps you can give me a solution, or perhaps together we can jam that thing. Then what is the structure of a comics? What should be the structure of a comics? How information flows on a page through comics and text in image and text in comics. How it should flow, like this. This is from Nilkam's paper, like simple 1, 2, 3, 4, 5. You can see that canvas is the whole page. Then is vertical, one. Vertical, you are seeing that thing vertically because of that image. Then horizontally you are moving. That means that your reading sequence is moving. So in this way, like tree. Horizontal, vertical, alternative way, So this is from this paper. Or like this. If you are doing that, suppose you are thinking coming in some bubble. So before I came here, I was discussing with Arindam, like, can we see this problem as a tiling problem or something like that? Like, or some different, how if you are using some different kind of geometric shape as the panel, not that restricted only rectangle or square. If you are using square, if you are using circle, and if you are using triangle, or other kind of like pyramid, cube, anything, like at least two-dimensionally, we can see at least like 3 of the faces. Like if we are really not drawing 3 faces, we can actually see if we are blocking the back side of the whole structure on two-dimensional if we are drawing. That is my like that upper, lower. How you are drawing actually it would matter actually. How you are drawing that pyramid actually. But can we use this kind of shape also? Because when I'm thinking, if I follow that rhizomatic structure and Nick Susan's argument that that spiral thing came because that follows that pattern. There is no such origin or some end, because in some closed system, what is happening in open system, something else is happening in terms of free energy. It was his argument. That's why he created that pattern. When we are thinking or creating or we are teaching any kind of science comics or any kind of scientific topic, what sort of argument we can create and what sort of metaphor in terms of pattern we can generate. Not metaphorical some objects. This is something else. Pattern, something else. Suppose it's coming in this way. Then how we can fill that image? How we can leave that white space? Is there any logic or is it just aesthetically random? I do not know that. That the question is in my mind. And I want to ask you actually. Or something like that. This is by Chris Ware. Like every thought is connected with each other. It's not like you are just done drawing some sequence or something like that. Because every thought, again, it dissected into some different sort of image and some information, and again more connected with each other. So what is the logic? What is the reading sequence of that? I do not know that. Okay? So that's the thing. So enough bakawas, let's do some comics and work on that topic. And let's discuss what we have discussed, through the slides we discussed today. Let's discuss while drawing also. Okay? So I hope that if you have any question, you can ask. While drawing also, we can do that thing. We have plenty of time. The papers are outside. We will volunteer to bring that, no problem. And you can use plenty of papers. I hope you all brought your pen and pencil. So any kind of idea you have, you want to convey. So again, like you really do not need to finish any comics or something. There is no such competition is going on here. Just jam thing, discuss with someone is sitting like juxtaposed to you. We can come to me. Sriram is here, other professors, like we can discuss together. And in between, if you want to really see like how this book actually look like, the books are there, all the hard copies. Okay, we can go there. Feel free to do that. So we'll start drawing now, and we'll keep discussing. Okay, and right now, if you have any question, I can attend that, or after that we can discuss. Okay, let's do it. So, yes, you have question? Yes. Yeah, rhizome is basically, it's a biological term actually. I don't know whether other kind of origin it has or not. Rhizome is basically in tree, so the roots, they are intertwined with some fungus so that they can help each other. So rhizomatic, like you can use a reticular structure like net, that would be same. No? So this is a very complex thing, it's connected to each other and there is exactly no such origin and some end. It's intertwined. Right. It's contrast to that tree-like structure. Okay? Yeah, something like some greed or something. So very interconnected. Okay, so yeah, let's go outside. Or can keep it here. Yeah, so let's bring those. Thank you so much. What we'll do now is we'll draw. So what sort of idea you have? What sort of drawing skill you have? Doesn't matter. How you are putting this idea, what I have discussed or beyond that. You can claim that everything was bullshit, it will be like that. Please do that. We really want to see. But yeah, let's discuss the logic why you
Okay, let's take a group photograph. Can everyone just assemble on the stage? Maybe that's a good place to have. I said everyone. I said everyone. Everyone on the stage. We'll do a group photograph. Okay, everyone except one. 30 seconds, let's start the photograph. Yeah.
Then, yes. Hello. 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 It's not audible. That thing, I guess. Yes, this is Ullas. Yeah, definitely. Hello. It is not working.
Guys, especially those who are not from IISc right now, can you please just stay for a few seconds? Just please come inside. Yeah, that's why. कहाँ पे? Okay, so guys, all those who are not from IISc, do you know about Open Day? Because we are organizing this event on 24th of February, which is on next Saturday. Okay, just wait for a few seconds, people are still coming. Till then, we can play the promo of that Open Day event.
लिंक मोकल नहीं वीडियो ने बनावा कई रीते वीडियो नहीं है या ओपन द वीडियो
So, like just let me tell you a very briefly about Open Day. All those who are not from IISc, kindly listen. So, on Open Day, what happens is that all the labs and the departments of Indian Institute of Science Bangalore are open for all the people, and I think the website would be displayed soon. So, what you can do is like similar to yesterday and today, you guys can also visit our campus on 24th of February and visit all the departments because there would be some kind of demos. The demos would be including interactive demos as well as maybe some research work demos. So you guys can also come to know about all the work that is being done in the labs, because many of the students were having doubts that what is the work being done in deep learning or some ML kind of stuff or maybe system stuff. So that's all. Just we are setting up the website for Open Day website. Okay, so since we are from CSA, so I would vouch for CSA because there are many exciting events at CSA on Open Day, and those involve quizzes, technical events. So there's an event called Technical Hunt. So that's proper treasure hunt, a virtual treasure hunt, in which obviously the clues would not be some kind of funny clues, but they would be including clues that would include some kind of problem solving, maybe analytical or maybe some logical problem solving. So it's a mix of fun as well as some technical aspects. And we'll be sharing the website. Please, like just a few seconds. You can also register to those events through that website. So simply go to, like, do a Google search CSA Open Day 2024. You'll find that website. So all the events are listed at the website. You can simply check it on. So I just mentioned about Tech Hunt. There are other events also like quizzes, Code Beta, and something like that. Other than that, there are some fun events which are completely like dart games and let's say puzzle solving. So you guys can simply come at CSA ISC, or other than that, you can also visit other departments excluding computer science and automation department. So we invite you for that. Okay.
You can add.
Okay, so there's also event called Hackathon. Unfortunately, the registrations are over now. We promoted it through websites, but you guys can still come and see what top 10 teams are actually presenting their work, and there's good presentation going on. So we actually formulated 3 problems. One of the problem was an open problem, and the goal of the problems are to use some kind of LLMs, large language models, to solve a problem which would be very interesting for a general public. So that's the website. You guys can see. So these are our official sponsors. And these are the list of events.